Hey students, lesson 5.8 here. We're going to learn how to graph absolute value functions and to translate the graph of an absolute value function. So a little bit of geometry here. Go ahead and do the review here. There's an important term you should take note of in the vocab. I'll check back with you. All right, we're going to do some translating here. So I just want to take a look at this real quick. So in this problem, it says write the equations of line 1 and 2. How can you transform the equation of line 1 into the equation of line 2? How can you slide line 1 on the coordinate plane so it becomes line 2? So we have line 1 right here. And the equation of that line is y equals 1/3 x plus 1. And the equation of the other line is y equals 1/3 x minus 1. Now, think about this. If we want to put line 1 where line 2 is, I could just slide it down 2 units. And when you're going down, that means you're changing all the y values, so all the outputs by 2. And notice in the equation, we changed what we're adding to it by 2. So we subtract, if you subtract 2 from 1, you get the other equation. So if we know a graph of an equation, we can translate that graph on a coordinate plane, and we can figure out what our new equation is just by the way we move it on a graph. And that's kind of what we're going to be doing here, only we're going to be using the absolute value function. Okay? So here's a couple graphs of some absolute value functions. And remember that an absolute value function takes any value, any input value, and turns it into a positive number or 0. It's never a negative number. And that's why we get this V shape right here, where all output values are in the positive area above the x-axis. So there are no negative output values. But all the input values are any real number, both positive and negative there. So anyway, the way these two graphs are related is they're really exactly the same graph. It's just that they both have the same slope. They're both going up by 1 here on this side and going up by going down by 1 on this side, I should say. So you'll notice that's the same here, same here. So if you look at it, the second graph is just, so this graph is just translated using the new word, translated from the first graph down, up 2 units from the first graph. So every output value is 2 more than every output value on the first graph. All right, go ahead. You do this. Got it? I'll check back to you. All right, so we can use that idea to help us graph a translation. If you think of, and you could make a table of values if you wanted for this, but if you think of this in terms of our function, our original function, our original absolute value function, and I'll use a dotted line to show that, was right here. And you should kind of keep that in mind, that the original absolute value function, or this is just y equals absolute value of x. All right. Now, when we graph this line, it's going to be a translation of that. And since we're subtracting 3 from the function, that means all of our output values are going to be 3 less than the original function. So what's going to happen is we're just going to shift it down 3 units. And that's really all you need to know to graph this. So now we want exactly the same slope, but just shift it down 3 units. And so that'll look like that. All right, why don't you try that? All right, so using that same idea, we can write equations for a translation of a graph. So if we're going to shift the graph 7 units up, that means we are going to add 7 to the outputs. So we want to add 7 to every output. And the way we'll do that is by just adding 7 to the function. So y equals the absolute value of x plus 7. If we want to shift it 5 units down, that means we want to subtract 7 from all the outputs, or subtract 5 from every output. And so our equation would be y equals the absolute value of x minus 5. All right, can you try that? All right. Sometimes equations will actually make a horizontal translation. So here we're going to do a graph. Instead of the subtract 3 being outside the absolute value, it's inside. And what happens then now is we're affecting the inputs. We're changing what our input values are compared to original function. So I'm going to go ahead and put the y equals absolute value on that x of x so we can see how the change is. So this is y equals absolute value of x. And to figure this one out, I'm going to do a table of values. And remember that the original function, or the normal absolute value function, would have these output values. So we're just changing each of these to a positive number. So 3, 2, 1, 0, 1, 2, 3. And that gives us the graph I already made. Now what I want you to do is watch how the values, the output values, change when we do this. So we're now doing the absolute value of x minus 3. So, and I think I'm going to leave a little room here, and you should too, because something's going to happen. So, I'm going to, if I input -3, so I'm going to do -3 minus 3, which is -6, and then do the absolute value, and that's 6. And then I'm going to do, actually, I'm going to change this to +3, so you should do that also. So we're going to do -3 plus 3, all right? So -3 plus 3 is 0, so the absolute value of that is 0. -2 plus 3 is 1, the absolute value of that is 1. -1 plus 3 is 2, and so on. And if I keep going here, these are just going to keep going up, 3, 4, 5, 6, and so on, okay? So I left a little room so I could put a few back here because I'm not seeing where it's changing and going the opposite direction. I need these values to do that. If I do -4 plus 3, I get -1, the absolute value of that is 1. -5 plus 3 is 2, that's -2, and the absolute value of that is 2, and so on. So here's my points now. So at -6, I'm actually at 3, which puts me right here. And -5, I'm at 2. And -4 is 1. At -3, I'm at 0. And then I start going back up again. At 1, I'm at -1, I'm at 2. At 0, I'm at 3. And so on. And so here's the points I get. And so you can see the V coming out here. And so I'm going to go ahead and make that graph right there, right there. And what I want you to notice is that from our original one, we actually shifted to the left 3. And notice in the function I'm adding 3. Now you might think that's funny, but and kind of weird, but we are touching 0 at 0 in y equals absolute value of x. it now takes an input of -3 to be at 0. So by adding 3 to the function, I'm actually getting the same input at the same output at 3 less. So essentially what's happening when we change the input, or when we put the function inside like that, you're going to shift opposite the direction that the number is going. So I'm going to let you try that. You should have noticed on that one that it shifted, subtracting 5 inside the absolute value shifts the function 5 to the right. All right, so we want to write equation for translation of x equals the absolute of y equals absolute value of x to make the function go 4 units to the right. So the way we're going to do that is we want, here's a good way to think of it. We want the output of 0 when x equals 4. Because on a graph, instead of going here to shift it 4 units to the right, we want it at 4. So we want y to equal 0. Right here is y equals 0 when x equals 4. Now to do that, we need to have this function. Y equals absolute value of x minus 4, because 4 minus 4 is 0. So the output of 0 will happen when x is 4. So to shift it 6 units to the left, we want an output of 0 when x equals -6. That'll shift it 6 to the left. And to get that, we need to have this function, x plus 6, because -6 plus 6 is 0. All right, you try that. Okay, so that's it for the lesson. Go ahead and do the lesson check, and we will talk about your answers the next time we meet in class.